2021, hosted by the Jean Golding Institute. And my name's Emma. I'm a data scientist at the JGI. So this is our 5th and final day of our Data Week online programme. It's been a week full of speakers and workshops showcasing the latest in data science and artificial intelligence. Before we kind of get stuck into the session today, I just wanted to go through a little bit of housekeeping really quickly. So please do note that this session is being recorded and the recording will be made available online after the presentation. So with that in mind, please do make sure that you've had a little look at the JGI Code of Conduct, which I think my colleague Chiara will put a link to in the chat. For the comfort of other participants, please do mute your microphone unless you're requested otherwise by the speaker or the host or chair. And we're going to be sending links in the chat to a couple of forms that we'd really appreciate you filling in. So one's going to be a registration form for the event, and then there'll be a feedback form at the end, which obviously for us, your feedback's super helpful to help us plan for future events and gauge how successful this one's been. And of course, please do try to interact, introduce yourself in the chat box, let us know your name, your role, where you're from. Hopefully we can get a conversation going. So there will be a Q&A at the end of the presentations in this segment, and we're going to be taking questions using Slido. So please do navigate to slido.com, or you can also use the QR code on this slide. We will post a link to this as we go through the presentations today as well. And if you enter your questions, we'll be putting those questions to the speakers at the end of this session. So as I said, Data Week is being hosted this week by the Jean Golding Institute. We're a central hub for data science and data intensive research at the University of Bristol. So we're one of the 5 university research institutes, and we connect multidisciplinary experts across disciplines in the university and beyond. We do have lots of international and national partners. So internationally, we collaborate with, for example, Strathmore University in Nairobi and the Institute for Statistical Mathematics in Japan. We also run events, training, we provide funding opportunities, and we also provide data science support and advice through our Ask JGI service. I just wanted to take a moment to flash up the timetable for this week. So as I said, this is the 5th and final day, but the programme's by no means over. We've still got lots of interesting talks to come, including this session that you're in right now. I did want to take a moment to just promote our lunchtime networking event, which we've got on today at 1 o'clock. That's going to be on the Remo platform. And it's just a really great way to kind of meet speakers, meet other participants, and just generally network and socialise a little bit. Of course, this week wouldn't be possible without the cooperation and support of our partners and sponsors. There are far too many for me to go through one by one, but I just wanted to flash up this slide to show our gratitude and due credit. We hope that you'll keep the conversation going, connect with us. You can get us on Twitter at JGI Bristol. We'd also really encourage you, if you want to keep up with our news and events, to subscribe to our newsletter. You can do this by going to our website at bristol.ac.uk/Golding. And we also really hope that you'll consider joining us for our next big event, which will be taking place next year in 2022. That's our big showcase. It will be in February. The idea being to showcase the latest interdisciplinary advances in data science and data intensive research. We're hoping to hold this at the M Shed in the heart of Bristol's historic Harbourside. So obviously the hope then being that this will be a family-friendly, public, face-to-face, interactive event where we'll have inspiring speakers, exhibitions, workshops, performances, and interactive displays. So I hope that you'll consider joining us for this. So at this point, I'm going to stop. I finished my introduction. I'll stop sharing my screen while the speakers prepare theirs. I think I'm going to be handing over now to Professor Nick Whiteley. He's a professor in the Institute for Statistical Science and Harbourne Chair in Data Science in the School of Mathematics at the University of Bristol. He's a fellow of the Alan Turing Institute and is director of the Compass Centre for Doctoral Training in Computational Statistics and Data Science. So if it's all right with you, Nick, I'll hand over to you now so that you can jump into your presentation.
Yes, thanks very much for that very detailed introduction. Thank you. Can everyone see my title slide?
perfectly.
Yep.
Thank you.
Okay, good. So fingers crossed. And now you can see my next one. Yeah, all good.
Yeah, that's
okay,
fine.
I'll keep talking. Thanks, Liz. Brilliant. So, what is Compass? Some basic facts to start with. It's a 4-year PhD training program, and the general scientific theme of the program is in computational statistics and data science. It's led by the Institute for Statistical Science, which is one of 5 research institutes in the School of Maths in Bristol. But that's just really the sort of the hub of the Compass activity. Our research has come from the university. Some of them come from the School of Maths, but we also have supervisors who, for example, are based in the Bristol Medical School, based in biological science, computer science, education, engineering, neuroscience, veterinary science, and so on and so on. But what links all these researchers together is that they're all working with data and they're all statistical experts. And I'll tell you a little bit more about who those researchers are and what kind of work they do in a moment. To give you a sense of scale, well, Compass opened its doors in October 2019, and we shall train approximately 50 PhD students over the lifetime of the centre and across 5 cohorts. So an intake in 2019, another in 2020, and so on to 2023. Another really critical ingredient of what we do, along with the students and the supervisors, of course, is that we work closely with partners from outside the university, from industry and from government agencies. My colleague Liz Wainwright, who's a partnerships manager for Compass, will go into more detail on that side of things later today. So some basic facts to start. How to now tell you a bit more what the ethos of Compass is and what it is that we're seeking to achieve. Well, of course, this is a PhD program, so it's all about training young researchers and helping them take their first steps in their research careers. So I think the best way for me to describe what we're trying to help those young researchers achieve is to tell you a little bit about some of the students themselves. And one of the things which Compass sets out to achieve is we want to be a gateway to research in computational statistics and data science. So what does that mean? It means that we seek to recruit students who may have a background in mathematics or statistics or some combination of thereof already, but they may not as well. We're also seek to recruit students, for example, from backgrounds in physics, chemistry, across the applied sciences, across the applied sciences and beyond, and help them to find their way into data science. So here are just 4 of our students who joined the program in October 2019. I've chosen these 4 in particular just because I wanted to highlight a few different things about their backgrounds. So Annie here on the left, she was an undergraduate in Bristol, and her background is in mathematics. And as part of her undergraduate degree, she spent actually quite a lot of time on applied mathematics, so thinking about fluid dynamics and those kind of things. And Compass is allowing her to grow her statistical knowledge and transfer what she knows about mathematics and applied mathematics over to problems from data science. Anthony here, bit of a different background. So he studied physics originally, and after his undergraduate degree, he worked for about 5 years as a data science industry. In fact, he was working on building statistical models to do with sporting events. Is to build up his knowledge of cutting-edge statistical theory and methods to complement all that practical experience he's got from his work in industry. Ed over on the right, another physicist originally who did work with analyzing particle physics data, and Georgie, with a natural sciences background, and spent time working as a research assistant in an epigenomics research group in Exeter before, as an environmental consultant, and now she's with us in Compass, developing deeper statistical methodological skills and theoretical understanding. So I present these four because they've got a range of backgrounds academically, whether they come straight from an undergraduate or master's degree and industry experience. And it's that kind of range of backgrounds which we really embrace. When they join the program, well, overall it looks like this. There's many elements to it, and this doesn't account for all of them by any means, and I won't have the time to talk through even all of these. But in general terms, a PhD program is of course centrally built around a main research project, as a PhD traditionally would be. In a CDT, extra things are come along with that. So in the first year of the program, there are dedicated courses which are put on in the School of Maths, which have been constructed specifically for Compass, which bring all the students up to a common level in core competencies across statistics and relevant bits of mathematics. They each do what we call a mini project in the first year, which is something similar in length to a master's dissertation, which is the precursor to the PhD research in the following 4 years. And then along with those core elements, there are many other ingredients. There's other what we call enrichment training activities or personal development training. So this is training in areas which are not necessarily directly connected with the exact topic of the student's research project, but help them to become well-rounded in their knowledge of statistics, in their knowledge of important matters around statistics to understand, like do responsible innovation, what it means to do ethical AI, public engagement, and so on. And then layered on top of that, we have activities which the cohort of students go through together. That's a really critical aspect of what we do. So that might involve special masterclasses that we put on, where we have internationally renowned scientists, statisticians, mathematicians, data scientists who come and give tutorials and special lectures for our students. It might be as a cohort going through training in how to conduct statistical consultancy. We have an activity called a focus lab, an industry focus lab, which my colleague Liz will tell you a bit more about later on. Or students as individuals or perhaps together may go and do an internship or on some kind of extended research visit as part of their PhD. And along with that, well, we've got activities through which we seek to build their general knowledge of the subject matter and to help them come together as a community, not only within the cohort, but with PhD students across the country. And we've got a student-led seminar series that achieves that. And we've also got a seminar series which is dedicated to industry. Again, my colleague Liz will say more about that in a moment. So these PhD projects start which are prefaced by the mini project in what kind of topics are involved. Compass offers a really broad range of research areas which reflects the ongoing and cutting edge research programs of its supervisors. And here I've just put up a selection of topic areas from year to year. The projects that students engage in, of course, change and reflect the ever-changing face of research across the University of Bristol. But to give you just a flavor of the kind of topics and projects which have been offered in the past, here I've just taken the first few of of our list, just so that you can see a few keywords, and you'll get a sense for immediately that there are some of these projects that focus on statistical methodology. You'll see immediately that there's some that might focus on a particular application domain. You'll see others which might involve working with a particular industrial partner, and so on and so forth. And when students join the program, there are more, loosely speaking, two streams by which they enter. Some of our students are admitted to the program and will then go through a process of being matched up with a project and a supervisor during the first half of the first year. Other students may join the program and are aligned with a specific project from day one. And we do that usually in the case where we've got projects which are co-supervised and co-funded by industry. We're very keen on the idea that the students get in the habit of communicating their thoughts and their work, not only the work they focus on as part of their PhD projects, but also communicating matters that they consider to be of importance and that they can hope to make a difference about using the statistical methodology that they learn about through the course. And one of the ways that we do that is through our Compass blog, which I really recommend you go and have a look at. Here I've just put a few snapshots up. You can see that, so we have a series of posts on our blog called Student Perspectives. Here you can see a post from one of our students, Dom, discussing a model he's devised for trying to analyze the air pollution in the city of Bristol. Here's another post from another of our students, Alex, discussing a really curious phenomenon from mathematical statistics, Stein's paradox. And here's a little clip of a post by yet another of our students, Maro, reporting on some of the consultancy training which our students went through as a cohort. So it's really a great way to get a sense for day-to-day what the CDT is about, if you go and have a look at that blog. In terms of how we support our students, we're very happy to have fully funded studentships which we're able to offer, and they include a generous stipend of nearly £20,000 a year, fees being fully paid, and on top of that, a quite generous budget to help support research training, travel to conferences, and so on. Recruitment for October 2021 is now nearly complete, with one key exception, and that's an open position on a project with AstraZeneca, which is advertised on our website here, and again, which my colleague Liz will talk a little bit about later. Recruitment for the October 2022 entry will open in the autumn, and the best way to find out about how to apply is to go to our website, which I've put up a snapshot of here. You'll also find there our LinkedIn profile, which we use to day by day to sort of broadcast latest news and opportunities with Compass. It seems a while since we've all been in our offices, doesn't it? I suppose, like me, many of you have been working from home or working in unusual circumstances for a while. But I wanted to tell you a little bit about where Compass is hosted physically, or at least where we physically will be, hopefully in the not too distant future. And that's the Fling, which is the home school of maths at the University of Bristol. We're really lucky to have the Fry building as the home of the School of Maths. It went under a renovation over the last 5 or so years at a cost of about £33 million, which transformed it. Back in the 19th century, this is an architect's sketch of the initial concept for the Fry building back then. It was one of the oldest parts of the university, which over the years had various wings built onto it. At some point it was the Department of Chemistry, and then it became the School of Biological Sciences, and then most recently it was remodeled as a school of maths. And that's where our Compass students spend the majority of our time. And I think what we've got to show you next is where you can hear a little bit more from some of our students. And watch out, because in the background you'll be able to see the Fry building.
The statistics department at Bristol really has a great reputation for working at the cutting edge and using really state-of-the-art ideas and tools.
The main advice that I got before joining the program was to make sure that you like the people that you're going to work with. When I came to the interview, and I was like, yeah, these are people that I could see myself working with.
The first year is full of talk courses, so you get to know the academics quite well, and that's really useful because usually standard PhDs, you have to choose your supervisor beforehand, but you get a year to try out a few different things before settling with the supervisor.
We have courses on computational statistics, on the theory of statistics.
Both of these, I'd say, had a really good structure in terms of the balance between the amount of teaching and the independent work that we got to do. It was definitely a good kind of challenge, and I guess that's the point, because that is when you learn, when you step outside your comfort zone.
My research area at the moment is in latent variable estimation, so I'm doing a lot of Bayesian filtering, which wasn't really something I knew about before joining the course. So it's another thing where it's great to have had the first year to look around the literature on a few different topics.
I'm researching change point analysis for time series, in particular high-dimensional time series. These are relevant to processing ECG data in neuroscience. They're also relevant in finance and risk management.
My current research is very geometrical. If we had some more robust statistical estimation for points on a spherical surface, then a lot of weather applications or more location-based measurements would be a lot more accurate in terms of estimation.
My project, I guess, isn't so much taking a statistical method and then finding applications for it. It's more, we already have an application, we have a problem that we're trying to solve, and what are the statistical methods and techniques that we can use to find a solution.
The whole program's really interdisciplinary. There's input from people from geography to neuroscience, and this has a really interesting bearing on the applications and the methodology that we work on.
We have lots of industrial partners. We'll give loads of meaty data sets to really get stuck into.
You have lots of idea of where your work could go in the future and what companies would be interested in it.
It's a beautiful place to study. We have a very nice office.
We also have blackboards all around the building, which is lovely because we can at any point just stop and, sketch some ideas.
You present to your peers and you get to learn from them as well as the feedback you get from the academics.
The collaborative nature of what we're doing is perhaps the best part of it.
We are such a diverse group of people, but it's great finding common ground in terms of our interests.
A few of us like to go to the gym together.
We often go and get lunch together in the common room.
Play a lot of sport together as well. That's really good fun. By the time it comes that I graduate, I think whatever I want to do, I'll be very well set up to do that.
Given that in recent years there has been a massive increase in data, I think statistical techniques have started catching up, and now we are able to work more and more on leveraging this data. I want to find a problem that I believe in and try to solve it.
I generally just like to keep doing research. It doesn't really matter for me whether it's with a university or whether it's with a private company.
I think this is probably the most employable type of maths.
I would say if you're thinking about applying to the programme, apply now. It's fantastic.
Brilliant. Okay, well, I hope that's given you a little bit of a insight into what some of our students think. You'll hear more from a couple of our students shortly. But next, I'm going to hand over to my colleague Liz Wainwright, who's Partnerships Manager for Compass.
Great, thanks, Dick, and thanks to my colleagues in the JGI as well. For those who've been to some other sessions during the week, you'll know it's been a really superbly organised data science week. and really great to be involved as well. So first of all, my name's Liz Wainwright. I'm the Industrial Partnerships Manager in the School of Mathematics. And I get to work with mathematicians and build collaborations with industry. So if you like, you feel free to follow me or link in with me on LinkedIn, and you can get in touch via this email address as well. I'll be at the networking session at lunchtime, so look forward to meeting a few more of you there. So who are our Compass partners? I wanted to give you a very quick whistle-stop tour of our partners, our industry partners, and tell you a little bit more about how Compass engages with those industries. Here you'll see a whole bunch of our partners. We have 22 industrial partners who support Compass in different ways. This slide gives you an idea of all of the different sectors that we pull those partnerships from. And just as Nick mentioned before, with our students coming from so many different routes to their PhD in computational science and data science, it shows that there's a very diverse group of partners from many different sectors, from health and education, all the way to finance and engineering. So these partners engage with us in very different ways, because each organisation has different priorities and different ideas and different interests. So in this session, me and colleagues are going to give you an idea of what it means to partner with Compass, and from a student's perspective, what it's like to work with some of those partners. So one of the most typical ways that an organisation might get involved with a CDT is to sponsor students. You've seen some of these words already in Nick's slides, but this shows you some of the projects that are currently sponsored by our industry partners. Here you'll see, of course, that we have one opportunity currently opening. I'll give you a moment to have a little look at that one. If you want to take a screenshot of that QR or anything like this, I'll just drop in the chat box a link to that advert as well to find out more about the open opportunity that we have with AstraZeneca for a fully funded PhD studentship. So Nick already mentioned that we have our own blog. We have the Compass blog. Whether you're a student or you're working in industry and you want to know more about what it's like to be a student on the Compass CDT, studying for your maths PhD, then I would definitely suggest that you have a little look at our Student Perspective series. This is the series that Nick referred to before, which is written totally by our students and has some really great blog posts on there. The blog is one way that we like to showcase the work that our students do, and especially the types of work, the work that they're involved in with their industrial partners as well. So as Nick said, there's quite a lot of different posts on there. Let me send you over the link to our Student Perspective series specifically, so you can take a look at those projects and those blog posts. So just moving on to examples about how our partners engage with us and what kind of research and training activities we put on with our partners. First of all, we have a Data Science at Work seminar. This is a brand new seminar series that we started this year, and we invite speakers from external organisations to talk about their experience as data scientists in industry. And the dual meaning of data science at work means that the talks focus on the technical side, the methodologies that they use in their industry. But the speakers will also talk about things like working as part of a wider organisation, a team that's developing new applications, and building a career in data science as well. I would say that, to Compass, our goal really is to make sure that we connect with technical expertise in data science, and in order to bring in the perspective of our industrial collaborators that students wouldn't necessarily get by only engaging with our academic team. Another way in which we've engaged with industrial partners is by running workshops such as industry focus labs. I guess they're kind of like data study groups. We've worked with partners such as Wessex Water, which Michael Whitehouse is going to talk to you about in the next presentation. So I won't say too much about it now, but it's a 2-week sprint style event where students work on a very focused problem. We also have some really great internship opportunities that are offered to our students. Students are encouraged to take up opportunities that take some time away from their studies and perhaps focusing on a problem that's not directly associated with their PhD topic. It gives students the opportunity to really make sure that they have a breadth to their PhD experience. And of course, for our industry partners who offer these types of internships, it's really investing in their future talent pipeline as well. And you'll see here some of the opportunities that we've had recently. And I've noted here where we've got some bespoke opportunities offered to students where organisations have pitched a specific problem that's very important to their organisation and recruited a student from the Compass cohorts. We've also run things like hackathons. Our latest one was with LV and focused on insurance claim prediction. That was held jointly with the Interactive AI CDT. And so it's nice that we get to kind of branch out and meet colleagues from different CDTs in the University of Bristol and get to work with them in teams as well. We like to make sure that we tailor all of our activities, though, to suit the organisations that we work with and the mathematical problems that are interesting to them. So this isn't necessarily a definitive list of the ways that we'd engage with our industrial partners, but it gives you a little bit of a whistle-stop tour. Okay, so I'm going to wrap up here. I think that I've already posted to everybody most of the links here to Twitter pages. Hang on, let me just drop these URLs into the chat. There's our Twitter and our Compass LinkedIn profile as well. Please do follow us. You'll get plenty of content that we push out about our research and our students. And finally, I just wanted to encourage you all to get in touch if you wish, drop us an email. Sure, and if you have anything that you'd like to discuss with Compass, or if you're a student that's looking to find out more about studying on the programme, please do get in touch. I'm going to go ahead and try and stop sharing my screen, and I'm going to hand over next to one of our students, Michael Whitehouse, and he's going to talk to you a little bit more about that Wessex Water Industry Focus Lab.
Hi everyone, can you all hear me okay? Yep, okay, cool. I will share my screen. Can you all see my screen okay?
Yep.
Yes, cool. Okay, so yeah, my name's Michael. I'm a second-year Compass student, and I'm going to give a very quick talk about the Wessex Water Industry Focus Lab. I know Nick and Liz have already plugged the blog, but I'm going to do it again. It's really great. You can have a look. This talk is loosely based on a blog post I wrote about the Industry Focus Lab experience. Okay, so what is the Industry Focus Lab? So the idea is that a company or some external partner from some industry will present the students with a problem they think that statistics and data science will be useful in solving. And hopefully they'll provide us with the data to help do this. It lets students work on high impact real world issues and gives the opportunity to apply skills gained in the taught part of the first year, be they theoretical or computational skills. So the first focus lab was with Wessex Water. They're responsible for providing us with clean water here in Bristol and to much of the southwest. And they provided some supervisors to work with, some internal supervisors to help the students go through the process, solving the problem. So what was the problem they provided us with? So providing water to most of the southwest, there's obviously hundreds and hundreds of miles of water piping, and inevitably some of these are going to leak, and obviously there's economic, environmental impacts of these leaking. So we'd like to know when they happen. So we're given the task of detecting pipe leaks from flow data. So the flow data looked a little bit like this. So I'm going to ask us to concentrate on, so here we've got in red, there's just raw measured values of some measure of flow. I can't quite remember what exactly it was, but it's some measure of flow. In green is the average daily value, and in blue is the minimum night value. And what we were told is that this kind of phenomenon around February 12th is characteristic of a pipe leak. So if we concentrate on the blue line, we see that between Jan 29th and February the 12th, it's kind of consistently noisy around, say, 0.6. And then after that, there's a systematic drop to around 0.5. And we were told that basically in general, a change in distribution of the flow data is indicative of a leak. So here we can see we've got a mean change in the minimum likely value. Yeah, so how do we detect these things? Well, change point detection. So what is change point detection? Change detection or change point detection concerns identifying times when a probability distribution of a stochastic process or time series changes. This is a highly active field. I know there are a few members of the stats department who work on this, and there's at least one of the Compass PhD students who does this kind of research full time. If you go on the blog post, then the post about the air pollution levels, that's to do with change point detection as well. Yeah, so that's really great, you can read that. So in order to detect a change in distribution, we need to model our data. We did that using GAMs, or generalized additive models. So don't worry too much about the intricacies or the complexities of this model. You can think of it as a linear model with lots of extra bells and whistles. So what we're doing is effectively, we've got this deterministic part here and this random part in the epsilon t's. So what we're doing is using features such as time of day, season, temperature to predict the water demand. So the flow, as we can think of the demand as water. The key assumption here is the residual errors, these epsilon t's, are all IID normal. So if you remember what I said before, a change in distribution is indicative of a leak. So what we're actually going to do is look for a change in the distribution of the residual series. So the change in distribution of this is indicative of a deviation from this model. And what we're going to do is, what we did was use a online change point detection algorithm. So online just means the readings are fed in sequentially, and instead of feeding in the whole series at once. This is intuitively more appealing because we'd like to do things in real time. I've provided a reference here to the paper for the algorithm we used. I'm going to give a very, very high overview of the algorithm now. So the first step is to calculate a mean estimate on some data we assume is stationary. So if we go back to our working example, we might feed in, say, Jan 29th to February the 5th. That looks fairly stationary. Calculate a mean based on that. We feed in new observations into the algorithm. We calculate test statistics. So this is following, classical hypothesis testing framework, and with accounting for multiple testing, so we're not doing anything too dodgy. And we calculate test statistic based on new data and see if these test statistics exceeds some threshold. So what we would hope to find in this example is that when we start feeding in data from, say, February 13th, 14th, then hopefully, if we've chosen our test statistics in a clever way, then they'll start to flag up change points. So the results from using this algorithm were somewhat difficult to find out because we didn't have leak data. So obviously, if we detect a leak, we'd like to check on some historical data whether this actually was a leak. But the nature of the problem is that they don't know when the leaks happened. So we don't have this massive data set telling us, oh, this is a leak that corresponds to this systematic change that we've seen in the time series data. What we did have was repair data. So this is used as a proxy. So if they've repaired a leak, then obviously a leak happened, but not all leaks are repaired for a myriad of reasons. So it's not the best proxy, but it works fairly well. And using this, the algorithm performed fairly well by this metric. So we had something positive to relay back to Wessex Water. So in conclusion, this marks a successful start to the Focus Lab. We've had at least one more since then, which there is a write-up of on the blog. And we've got plenty more planned for the next few years. It gave, so I know Nick mentioned earlier that one of the key aspects of the course is giving students opportunities to gain experience in presenting to a wide range of audiences, and this gave us a opportunity to present to non-expert decision makers. So what I mean by this is like directors and executives who don't have the technical knowledge of all the the statistical complex things we're talking about, but they are high power decision makers and they're responsible for big decisions. So it's not a case of they need to understand this, but they need to be convinced that we do and we know what we're talking about. So I found that aspect of the Focus Labs probably the most interesting part. And maybe more importantly, you got the feel for what life is like being a professional statistician. So to go from the problem statement to finding a solution and then delivering it to your client. So I think that's all I've got. Yeah, so thanks for listening. And yeah, if you've got any questions at the end, I'll stick around for them. And here is a reference if you're at all interested in the really complicated change point algorithm that we used. Thank you very much.
Thanks, Michael. That's fantastic. I think in the interest of time, I'm wondering perhaps we can go straight to Jake now, if Jake, you're ready, and then
Yeah.
questions after that.
Sure, that's not a problem. Okay, I'll share my screen. Okay. Oh. Okay, can you see my slides? And can you hear me?
Yeah.
Okay. Okay, so hi everyone, my name is Jake and I'm also a second year PhD student with the Compass CET. And today I'm going to very briefly talk to you about my research on non-parametric inference using kernel methods. So we're going to start quickly by motivating the use of kernel methods, and we'll do that by this clustering problem. So I've given you this data on X and Y, and quite clearly to you and me, there are two clusters contained within this data. We have this red cluster of data and this blue cluster of data. But I present this problem that if we were to approach this problem using a linear classifier, then we would not be able to effectively identify the clusters. And the problem is that a linear classifier would try to draw a linear line somewhere on this plot to separate the clusters. And because of their structure, it's just not possible. So what I suggest that we can do is we can take our data XY, which is in R2, and we can map it to a higher dimension feature space, R3. So we change, so we take XY and we map it to XY and X squared plus Y squared. And now in this higher dimensional feature space, quite clearly there's some linear hyperplane that separates our clusters very clearly. And so my takeaway is that mapping data points to a high dimensional feature space makes the problem solvable by a linear classifier, or at least it makes it closer to being solvable. And there is another way of thinking about this, and that's that if we were to take that linear hyperplane and we were to map it back to this original plot, rather than having our classifier be a linear line, it would look something like a circle around this blue cluster. So in that sense, we've taken our estimator, which previously was linear, and we've now made it more flexible by projecting our data to a higher dimension. And that is what kernel methods aim to do. So kernel methods provide us with a flexible and powerful estimator by taking our data and mapping it to a high dimensional feature space. And in the interest of time, I'm not going to write down any equations. I'm just going to give you this illustration. So we take each data point and we map it to a point in our RKHS H, where an RKHS is short for a reproducing kernel Hilbert space. And that sounds complicated, but an RKHS is simply a function space with nice and intuitive geometry, much like Euclidean space. And it also has this reproducing property that allows us to keep our costs finite. So I haven't mentioned it here, but this feature space is in many scenarios infinite dimensional, but our cost remains finite. And so we can generalize this idea a little further. So rather than embed a data point into our RKHS, we can extend that such that we can embed any measure into our RKHS. And that is what's shown here. So I've taken these probability distributions, and this is just an illustration, but we are embedding these probability distributions as a single point in our RKHS H. And perhaps the most important aspect of these embeddings is that they are unique. So for two different distributions, P and Q, we will have two distinct points in our RKHS. And perhaps the second most important thing for my research is that we can conduct kind of probabilistic operations within the RKHS. So there are kernel versions of the sum, product, and Bayes rule, which allow us to take a single point in our RKHS and either map it to another point in the same RKHS or to a new RKHS. And in doing that, we are conducting non-parametric probabilistic inference. So to give you a quick example, suppose we had samples X and Y, and we were interested in modeling the conditional distribution of Y given X. So without kind of making parametric assumptions on either the distributions of X or Y, we could simply use those samples to embed the marginal distribution of X into our RKHS. And then we use the sum rule to map that to a new RKHS, and that corresponds to the embedding of Y given X. And these are the kind of things that I focus on in my research. So currently I'm working on a non-parametric method for hidden Markov models. And hidden Markov models are simply a time-evolving statistical model. With various applications, I've named a few here. And the general idea of a hidden Markov model is that we have these observations YT, which evolve over time. And we believe that there is some underlying process in the background which we can't observe, which kind of determines our YTs. And we believe that that process can be at least adequately modeled as a Markov chain or a Markov process. And in fitting this kind of model, there are a few things that you might be interested in. So for example, you may be interested in understanding how this hidden chain evolves over time. You may be interested in understanding how our observed states, YT, are distributed given the hidden state, XT. And you may also be interested in things like the invariant distribution. And so currently my research is focused on using the methods from the previous slide to estimate these things that we might be interested in a non-parametric way. Okay, and that is all I have. Thank you all.
Thanks very much, Jake. That was brilliant, very clear. Right, so what time is it? 10 to. I believe we're supposed to leave some time for questions. Is that correct, Harriet?
Yeah, Emma, I think you were monitoring the Slido for any questions that might have come in.
Yeah, that's right. We do have a few. Would now be a good time to ask them? You didn't want, I know that you had another video, but would you prefer not to show that and dive straight into the questions?
I think I'd like to give people a chance to ask their questions and have them answered. We can always post a link to the remaining video later.
I think that sounds like a very good plan. So thank you. In that case, if it's all right, I'll read out some of the questions that we've had on the Slido, and you can determine who's the most appropriate person who'd like to respond to each one. So we have one question from Tina, who says, I have a background in pure mathematics and I'm now working in IT. Do you consider students who have been out of academia for a while as candidates?
Absolutely. Indeed, if you remember when I showed you 4 of our PhD students, 2 of the ones on that slide they joined the Compass program maybe 4 or 5 years after they completed their previous studies. And that's just an example, you know, that there isn't necessarily a maximum amount of time after studies, but short answer is yes. And we certainly welcome applications from people with backgrounds like pure mathematics as well.
Thanks, Nick. Another person is asking, what is involved in undertaking an internship with industrial partners and how long are they?
I'll take this one. I'll take this one if you like. So ordinarily, what I do is I talk to lots of our partners and ask about types of opportunities that they have upcoming, and so that they get access to market these posts to our students. If students are interested, then they can apply. Sometimes it's a competitive application. Maybe it's a nationwide call, for example, if it's one of the larger organisations such as IBM Research. And what we do, Harriet and I, we support students in making sure that their applications are ready to go ahead, support them through the recruitment process if they need any help with interview techniques and things like this. And if they are successful in getting an internship, then what Harriet does is make sure that all of the behind the scenes admin is done so that they can pause their studies and their funding is paused so that they can get that additional time at the end of the PhD. Typically, we'd say that an internship is probably going to be about 2 to 3 months, but that really just depends on the supervisor, on the student, on the project itself. It can be a little bit longer.
Thanks, Liz. That's really informative. I just want to ask, so we're having a couple more questions on kind of entry requirements and stuff. So I'll just ask this question, and maybe we can also comment on kind of the numbers of applications that you tend to get each year and things. So this question is, I did my bachelor's in mathematics and now I'm doing a master's in climate change. Would this be considered as a good fit for Compass?
Yeah, sure. I mean, yeah, could be a great fit. The technical entry requirements you can be found by looking through the links that are on our website, but what it comes down to is the basic entry requirement is a 2-1 or equivalent in a mathematical or statistical subject. So that doesn't have to be mathematics or statistics itself. As I mentioned in my talk, it could be, you know, physics, chemistry, could be the mathematical end of economics, could be someone who's worked in statistical genetics, and so on and so forth. Harriet, would you like to comment on numbers?
Yeah, we sort of consistently get about 150 applications every year, and we expect to have between 10 and 15 as an intake for each cohort every year.
Thanks, Harriet. Yeah, that's good to get an idea of the numbers. We also have a question about applications for 2022. So apparently in the prospectus it says the application deadline is the 2nd of August 2021. Is this the deadline for 2022 start or 2021 start?
The 2021 deadline is the deadline for September 2021 entry. So that cycle will finish and then the new cycle will begin, as Nick said, sort of later in October, November time when they open the new application system. And the deadline, the official deadline to apply will be August again, the following year, 2022. But what tends to happen is the funding is done in rounds. So if you want to be considered for a funded place, we recommend people apply earlier on in the cycle, so December or January time, to make sure that we've got the funding available.
Thanks, Harriet. And I see Liz just posted a link for applicants' information in the chat as well. Thanks, Liz. Sorry, Nick, did you have a follow-up there?
I just to reinforce what Harriet said, I think sort of November, December, January is peak time for applications nationally, but especially in our kind of area. So apply sooner rather than later. That August deadline is sort of that's technically the last kind of possible date at which someone could apply and possibly be admitted, but we expect our recruitment to be wrapped up usually by around the spring for entry into the program in the following autumn.
Okay, thanks, Nick. Someone's also asking, how do we choose our area of interest in the PhD, as I don't know much about the subject areas?
Yeah, so one of the great things about a CDT is that it gives students an opportunity to get some exposure to different areas. That being said, there's no substitute for starting to think about what your interest might be in advance. And so our recommendation to all applicants before they've applied even, have a look on our website, have a look at the research areas. You'll be able to click through, see our supervisors. There's a link to the latest publications from our supervisors. And there's no substitute for doing that sooner rather than later. When students apply, we ask them to write a written statement which talks about their background and about why they think they fit with Compass. And we like to hear from students at that stage what they think their interest might potentially be, but we don't require a very detailed research proposal to be written. When the students join the program, assuming they're not already assigned, for example, to an industry project, which might be advertised and recruited to specifically. So the remaining students will join the program, and then during the autumn term, we have something called the Supervisor Showcase, where our academic supervisors will present over a period of weeks their own research and the possibilities of doing PhD projects with those researchers. And then once those presentations have been made, we have basically a list of projects and project proposals which our students have access to. The students then submit their preferences after talking to the supervisors submit their preferences, and we do the matching.
Okay, thanks. And I suppose kind of related to that, there was a question about whether all students are paired with a single industrial partner for the duration of their PhD, or if they'll get to interact with, a variety of partners throughout their programme.
Yeah, so some students are recruited, as Nick just mentioned, directly onto a specific industrial project. They'll have an industrial supervisor as well as an academic one, sometimes jointly supervised by a couple of academics. But this isn't a requirement, and not all students are sponsored by an industrial partner. However, all students across all of the cohorts have plenty of opportunity to interact with all of our different partners, and that's why we run so many different types of activities with our partners. These hackathons or a workshop, or just getting to meet them at seminars as well. So our Data Science at Work seminar series is a really great example of that, because the speakers come in from industry and talk about their work, the scientific work, as well as establishing a career in data science and industry. And then after the seminar, students get the opportunity to network with our industrial partners, which networking sounds like a really grand way of saying taking them out for a cup of coffee, having a good conversation with them, kind of getting to know people in those industries, as well as hearing what they do for work.
Thanks, Liz. Yeah, well, that's exactly the kind of interaction that you want, I think. So it's 1 o'clock now, so I think we're going to have to close the Q&A. Are there any closing remarks you'd like to make? Anyone on the panel? If not, then all that's left is for me to thank you all for a really informative and interesting session. I think we had some really good questions as well. I'd just like to say that now we do have a networking event, a lunchtime networking event, which you're all very welcome to join. There'll be a link for that in the chat. Nick, did you have anything that you'd like to say in closing?
No, thanks very much to everyone for attending. Thanks very much to you and everyone at the JGI for organising.